All right, guys, so we are on. Let's just wait a few minutes to just wrap up and double check if everything works. So please add Zbigniew to the table. Just let me know that you hear us properly and see us. Just double check before we'll run the webinar.
Hello.
No, just without camera, Zbyszek. We can disable the camera and just, yeah, it's good. Let's check the double if you can change the presentation right now.
No, I can't.
Okay, I can. So no worries. So let's wait because we have some technical issues. No worries here.
I don't see the Blackmagic camera.
Daj mi mute. Idziemy z info. To on nie musi mieć kamery, ja też nie, zauważ. Wszystko idzie od ciebie. Przecież to ty sterujesz. Motasz teraz, Szymon.
Ja mogę wybrać tylko zintegrowaną albo
on ma tylko szerować ekran i szerować prezentację, tyle. A całość sterowania oboma idzie od ciebie. No, źle go wprowadzasz. On nic nie dotyka, żadnego Blackmagica. Dobra, wracamy i startujemy. Okay, apologize. So we have some technical troubles. So let me just jump into the presentation. So Zbyszek, just let me know if you would like the next slide. So I will change it. Then we will go into the live demo mode. So welcome everybody, OVP webinar. Zbigniew Parys with me from the Red Hat. And today we have a pleasure to share with you why the 5 reasons why we should go into the OpenShift virtualization. Open virtualization is quite hot topic these days because of the few things that happened in the last years. One, the reason is that Red Hat officially told that this is the future of the virtualization stack. And in the next years, it will move the most of the Red Hat virtualization workload into the OpenShift virtualization. We'll deep dive why and what is the pros and cons of the technology. Secondly, because of all of the Broadcom acquisition of the VMware, there's lots of rumors what will happen with the other players. Which works on the KVM technology. So I'm also keen to hear this kind of the presentation. But let's first just jump into the Zbyszek. Zbyszek, please introduce ourselves. It's not our first webinar, but for those who are at the first time, definitely it's worth they will know you.
Yes. Hello, my name is Zbigniew Parys, Zbyszek. I am solution architect in Red Hat. Generally, I focus on the infrastructure part of the Red Hat portfolio. I mean the operating system, storage, which is still a little bit in the Red Hat, and of course the virtualization. I start in Red Hat virtualization, next will be OpenStack, and now I switch to the OpenShift virtualization, which in fact is in the same technology when we look underneath.
So the question after the presentation will be, but I will start actually with this question. Absolutely. Is it worth to move into the OpenShift virtualization?
It's a little tricky because OpenShift virtualization is not a classical virtualization, but is many functionality which is similar to virtualization, but some functionality will, broke your traditional approach to the virtualization. I try to explain what I mean.
Mm-hmm.
Okay. At the beginning, this is not a new technology. Because please next slide, because this technology will try to combine the old approach, I mean pure virtualization, and new approach, which is containerization platform. What it means? Please next slide. Putting a virtual machine into the pod, into the container pod, gives you some special functionality. For example, you can combine workload virtualize and combine the workload containerize into the same project using the same resources, using the same network. This is a simplification of your architecture because you don't need to manage, how to say, two separate worlds.
So let me just see. The goal is to put the VM on top on the containers engine.
Not at the top, on the same level,
Okay,
like container. That's right. Because the YAML, which is describe object in the Kubernetes. In fact, YAML is on a representation of internal database in the Kubernetes. But yeah. Okay, but the YAML which describe the pod, the classical pod with, I mean container, and the YAML which is described virtual machine is very similar. Okay, the naming of the object, some resources was different, but in fact the manage is on the same level. Okay, this is a shortly explanation what this technology work. Of course, we have KVM as a main virtualization engine in the world. This is exactly the same virtualization engine like we're using in Ref, like we're using in OpenStack, or for example using, I don't know, Nutanix in his virtualization platform.
So it's a libvirt plus QEMU. So
that's
this is
right,
what we see here.
That's right. This is the reason what I put this point as this is not a new technology. Technology is rock solid, is stable, have about 15 years on the market. But what is the biggest differences is how to say manage of this object, because we're switching from pure libvirt to the object which is built in Kubernetes. And this Kubernetes object will create information for libvirt as a running, how to say, runtime to create a new virtual machine or to restart virtual machine or to give access to some network, some storage, etc., etc.
Okay. So, like you said, it's just on the same level as a container at this stage.
That's right. I try to show because when we switching to the live demo, I drill down to the pod and show you the XML, which is in fact describe the virtual machine similar like in Virt Manager or Ref or I don't know, other technology based on the same functionality.
Yeah, and we will be curious about the way how we manage it. Yes,
that's
so
right.
if it's the same philosophy, but you will show it. So
yes, there is a many similar functionalities, similar approach, but other is completely different and based on the changing your mind to the Kubernetes, not pure virtualization. Okay, like we already said. Underneath, we have QEMU, which is engine to start up your virtual machine. We still have libvirt as a layer to spin up this virtual machine. And the new part of this, how to say, cake is Virt Launcher. Virt Launcher is, in fact, the engine which is between the Kubernetes world and the virtualization world to spin up your virtual machine. The element which is using is again old, stable, long time implement in the RHEL, in the Ref as a base of your virtualization platform. There is comparison between the Ref, between the OpenStack and the OpenShift Virtualization. As you see, many layers is exactly the same. as I mentioned, only the describe of the object, the functionality of manage this object is a little bit different. Please, next. What is the new from this point of view? The virtual machine networking, because this part of the functionality based on this functionality which is already implemented in the OpenShift in the Kubernetes. For example, you can using OpenShift SDN, you can using OVN Kubernetes as a network layer, and of course you can use still all bridging technology, similar like in VMware, similar like in Rev, to put directly access from your network through the maybe VLAN to your virtual machine. You can combine both of these approaches on the same machine. So you combine the new approach and the classical approach in the networking layer. Here it's an example configuration. As you see, there is some virtual machine which is connected to the OpenShift SDN and connected to the bridge directly to your network. So still you have access to your, I don't know, old environment. You can combine this environment to the virtualization network. And again, you can use a very advanced SDN, which is implemented in the OpenShift in the same time.
The question is from Marcus: will the container and the VM will simultaneously run on the same machine together?
That's right. There is an idea. On the same physical host, you can run virtual machine and you can run a classical container using the same resources, using the same network. They both can be in the same project to isolate, for example, resources, to quotation your resources in the same way. Storage is a very crucial still point of the technology, because when the container was invented, we discussed many times, the persistent storage is not a, how to say, idea at the beginning of this technology, because the ephemerid storage is this part of the, how to say, storage technology, what is exactly invented for the containers. But of course, the reality was changed this approach. We need to have classical storage. We need to have some storage which is still available after, I don't know, restart the pod, etc. We can using classical access like NFS. We can using every technology which is implementing the Kubernetes on the in the OpenShift through the CSI drivers. Of course, you can using OpenShift Data Foundation, which is SDN from the Red Hat based on the Ceph technology. Next, please.
Yeah, just got some few more questions. So
sure.
If we have is any new tuning options for the bare metal implementations of physical machines, etc. Do we have any of those, let's say, recommendation, or is it typical the actually OpenShift tuning part?
It is built in the CoreOS, because the base of the OpenShift is the CoreOS operating system, which in fact based on the Rail technology. There is a many option which is automatically tuning for the bare metal implementation. Generally, in this approach is doing by the machine config operator, which is part of the OpenShift baseline to manage physical or virtual machine, which is OpenShift workers.
So it goes into the another question, the best performance from containers and VMs running together. So is there any differences, or because we used to have, we're thinking moving VMs into the containers, I think we have the old thinking how to
Mhm.
properly tune the virtualization engines. Here right now it's a little bit different story.
That's right. It's already done. It's
Mhm.
done by the OpenShift Virtualization operator. The OpenShift Virtualization operator, which I show you in briefly, during the deployment, create a special object and special API to manage virtual machine into the pods. So it's, in my opinion, already done. There is not a huge field to improve this process. Okay, easy to install and use.
Oh, sorry.
Yes,
Not as fast as it should
that's
be.
right. That's right. Easy to use. Why? Because we are using operator, which is some kind of technology which is implemented for the OpenShift to create a smart technology to manage host, to manage OpenShift itself, to create some new APIs, etc., object in the OpenShift, etc., etc. During the deployment, OpenShift on the bare metal, in the few just clicks, you can create OpenShift cluster in your environment. I show you how to do this.
So please share the screen again because I disable it. So,
Okay.
so you need to share the screen and we'll zoom out. Yeah, got it.
Do you see my screen?
Yep.
Okay. So this is my OpenShift cluster. It's nested virtualization, which is absolutely fine to laboratory, but it is not supported in the production environment. For the production environment, Red Hat strongly suggests to using OpenShift on the bare metal. But the installation of the OpenShift is very easy. You just click on the operators, jump to the operator hub, and just find the proper operator. There is many operators, and here is the OpenShift virtualization operator from the Red Hat. Last days we announced the new version 4.12.2. You can find information what is improvement and just install this operator. This installation have already done. Next operator will be maybe half this process, called MTV. It's Migration Toolkit for Virtualization. This is a small operator, can grab virtual machine directly from VMware or from the Revit and put in the OpenShift virtualization platform as the new object. Again, you can install, of course, like I mentioned, both operators have already installed.
So question, MTV, it's for what kind of the sources you can use it for migration? It's
I show you.
Okay.
I show you. After the installation, you just need only create a new hyperconverged deployment, and that's all. After this, you have access to new object, the new object called virtualization. You can click the overview to show how many virtual machines do you have in your environment. You have information about top consumer, you have information about migration to this machine, etc., etc. And that's all. After this, a few clicks, you have running virtualization environment in your containerized platform.
So you don't need to decide on which, so it's also clustered. So how many, it depends how many hosts you have. It's already load balance between. So you don't need to choose the specific host, I guess.
You can choose specific host, but if you don't create special filters Deployment will grab every of your machines.
Okay, shall we move on?
Yes, please.
Operator. Okay.
Easy to migrate current environment. What I mean, if you have current virtualization platform, Ref, OpenStack, not OpenStack, Ref, VMware, you can very easily and safe migrate your virtual machine from those virtualization platform into the OpenShift virtualization. Why safely? Because we don't change anything on the source. We just shutting down this machine through the API. And after this, we grab the configuration and the disk and create for you the new object in the OpenShift. And if the machine will be started between the process, the machine will be started after the process. If the machine was stopped on the source after migration, machine will be stopped too.
Plus one question: Is it possible to deploy VMs where to then deploy containers on top? Starting a bit little crazy. So
yeah,
but is it, theoretically it's possible?
It is possible. It is possible.
Okay,
yeah, it is possible.
It's like on old like on a KVM.
That's right.
Run the OS and then containers.
That's right. It is possible. It's possible. I don't think we have installer to do this in automatically way, but technically it is possible. Maybe the how it name. There is some kind of approach to the deployment OpenShift called not individualization.
Never mind. Let's move on. Okay. So
okay.
MTV. Let's go to the live demo. So if you could share the screen again, Zbyszek.
Sure.
Let me just wait here. Yeah, so you need to jump.
Do you see my screen?
Yes.
Okay.
So if you could just, if it's possible to just a little bit zoom in. Yeah, it will be better for the audience.
After deployment, the MTV operator, migration toolkit for virtualization, you have access to this web console through the UI. It's very similar UI like for OpenShift. And there is a question about providers. I have in my environment RHV as a provider. You can add another provider. Provider will be maybe VMware. You just fill out this simple web page, and that's all. If the connection was properly, you have information about the status is ready. Great. We're able to grab the first machine from the OpenShift, from my ref to the OpenShift. It's done through the migration plans. The migration plan can grab single virtual machine, or for example, can grab many virtual machine, which is connected as a single application. I don't know, the database, there are some web service, etc., etc. I show you how to do this. Create a plan. Name of the plan, demo2, source provider, demo3, source provider RHV.
Somebody did the demo too, I guess.
Yeah. The target provider host, it's mean exactly this environment which is deployed MTV. Of course, if you have many cluster, single MTV can deploy your virtual machine in the other clusters.
Okay.
The namespace. The namespace is in the Kubernetes, in the OpenShift world, name of some resource, or how to say, the object with grab every of your part of your application, including the resources, including the secrets, including the storage, etc., etc. I have already created a VM demo project. Next. I grab this information from cluster default. Next. There is a list of every virtual machine that can be migrated. I have own. There is a two machine which is started at ZPR demo. It's some warnings. Why? Because, for example, the OpenShift virtualization don't support USB through the network. There is information about pool affinity. What it mean? It's mean if the storage have RWX access mode, the machine can be live migrated. If the storage don't have these capabilities, I'm sorry, live migration is not available in this time. The memorable link is enabled, and still, it's currently not supported by OpenShift virtualization like you see on the screen. The last part is the cluster has KSM enabled. KSM is kernel stampage memory merging mechanism, which is defragmentation memory on the fly. This functionality is not available in Kubernetes. I put this machine as a demo. Next option is mapping the network between your ref or VMware and OpenShift virtualization. There is two approaches. The first is using OpenShift SDN, or you can use pure bridge, similar like I have configured in the ref. I put this machine exactly the same network. Then after migration, I just click the spin up, and this machine was connected exactly in the same way like in the ref. Next mapping is the storage mapping. I create storage mapping. This machine have two disks. The first disk is in the VM store, the second disk in the data store. I migrate both disks in my storage domain called Ceph RBD. This is a block access in the Ceph. Next, type of migration, call or war migration. It's mean if the machine is running, the MTV can create a snapshot and waiting to the cutover process to finish the snapshotting process and shutting down a machine on the source. And after migration, spin up this machine on OpenShift virtualization. And that's all. We have a plan. There is the summary of this plan. Finish. I didn't start this process because in my environment, the migration was consumed about 10 to 50 minutes. I have already migrated machine. I show you. Again, this is single virtual machine migrated from ref. We can deep click to show what exactly steps will be done. Initialize, transfer the disk, and convert image to the kubevirt. As you see, the machine called Vin, and this machine is already running on my platform because, of course, we support Windows 2 as a guest operating system. Here it's a console. Here you are. This is this is the Windows machine running on Linux.
Yeah, that's what you know. What all of your friends right now saying he's crazy. You know, he just showing the Windows, and he's from the Red Hat team.
That's right.
So,
by the way,
I believe you don't have a Windows on your here. Yeah.
No. I'm using Fedora.
Okay. Just double check.
Okay.
Just double check.
But by the way, this is supported platform for running the Windows virtual machines.
And we have a question to use Zbyszek. So, possible to scale up the VMs like pods if we have the same dependencies?
Great question. I mentioned about this functionality in the end of this presentation because this is a tricky question.
Okay, so we'll come back to it.
Yes.
Thanks. Let's move on. So let's come back to the presentation mode.
That's right.
So we are after the MTV demo. It's really great and easy of use. The point 4. So we are
yes.
starting to be closer to the final
That's
conclusion.
Right. It is very easy to adopt current workflow based on the using the templates. And of course, it's very easy to implement the new workflow based on the GitOps approach to create every of pieces of your infrastructure. I show you this classical approach. I have in the company guys who better know how the GitOps idea put in the OpenShift. So we switch back to the.
Okay, let's jump into the. So we need to jump into the different tab, Zbyszek. Yeah,
yes,
we got it.
Okay. I mentioned that it's able to create virtual machines from the templates, like in VMware, like in Ref, like in rest of virtualization engines. I switch to my favorite VM demo project, and I create a machine from the catalog. I create a virtual machine with rel 9. And if you don't need any to customize, you just quick creation virtual machine. I need to customize. Why? Because, for example, I need to change some parameters. Maybe I need to change the password for a cloud user. Next. I, for example, need to have put some SSH key into the machine. Edit. Attach existing secret. And that's all. The machine can be created with custom password and my SSH key. Create a virtual machine. After the creation, machine will be automatically spin up. Wait a second. As I mentioned, this is nested virtualization, so this is not a very fast environment. But as you see, the machine is created, the pod is created, the disk was created from the template, putting as a booting device to this machine. Wait a second. As you see, the machine is booting. I show the larger console. Funny things, the number of the task is based on the number of the processor in your virtual machine. Wait a second. This is final reconfigure and done. We have new virtual machine. How to access to this virtual machine? It's not easy because I put this machine into the pod networking, which is in fact the masquerade. This is not technology. But how to access to this machine from my laptop? It's easy. Click on the detail. Here is the connection string using virtctl binary. I just click. I open my terminal.
Okay, so it's got some token, a user. Actually, with everything.
Not token.
It's password.
I put my SSH key.
Okay, SSH key here.
That's right. Wait a second. Here you are. This is new machine. As I said, the address is from completely different world, like we expect, but I still have access to this machine. Of course, we can create other type of this action access. For example, we can create the node port on host to access directly through this particular worker to the virtual machine. Of course, we can access to the console. Here you are, like in normal virtual technology world.
Yeah, because we are used to use the templates, especially in the virtualization.
That's right.
So it's a natural way.
That's right.
From all of the VM admins. Okay, right. Let's move on.
If you want to show what is underneath, we can jump directly to the pod. we can open the terminal to the pod. Do you know what this command?
Wish list.
Yeah.
To list all of your VMs.
That's right.
Double check.
Here you are. This is my virtual machine.
Like in Virsh. Yes, so this is what we said, the same set of
absolutely
libraries.
Exactly the same technology, exactly the same XML that provide information about every aspects of your virtual machine. Exactly the same technology.
But from the YAM perspective, if you could
it's completely different.
Okay. Story, yeah. So
yes. This is the full description of the VM machine object, from which template, which disk, which network, etc. This is full describe about your virtual machine done by the Kubernetes object called VM. Okay, let's switch back to the presentation.
So we saw the VM demo.
That's
and
right.
Number 5.
This is not replacement of the virtualization technology. Please, next slide, which is very important. This is the platform for containerized and non-containerized workloads running on the same platform, on the same hardware, on the same technology, with the same network, with the same storage, etc. This is not replacement for your virtualization platform. This is new platform when you want to combine old approach, or I don't know, legacy application, legacy server that can be don't decompose to the microservices, maybe using old Microsoft technology, etc. If you don't have ability to put your application in the new modern way as a containers, you still can grab whole virtual machine and manage this virtual machine like OpenShift pod, OpenShift object, and in the same UI, in the same CLI. Okay, please, next slide. Here it's how to say, the picture showing that the virtual machine and pod will be using together in the same project with the same connectivity. So you can use exactly the same technology like service, route, ingresses that can you have for your new modern application to put every of these pieces into this platform. Okay, typical misunderstanding of the technology. What I mean, some functionality is similar, as you see in RHV, in OpenShift Virtualization. We can using live migration. We can using similar network technology. We can using similar technology, but in different name, like Ref has storage domain, vSphere have data store, and on the Kubernetes we have PVC, physical volume claim, etc. So there is many options, very, very similar. Next, please. Okay. First surprise, how to rename a VM in OpenShift Virtualization? This is open question.
Open
for
question.
You too.
Open question.
For you too.
I don't know. I don't know in person.
Okay. I show you something, which is
please share, because I disabled the sharing. Sorry for that. I thought that will not share again.
No problem. There is no button to share.
Disabled.
Okay, I describe what I.
Yeah, let's describe
that's
it.
Right. There is a special field in the YAML called VM name, which you probably want to change. If you try to do this, you got information about, I'm sorry, this field is protected. It means there is no easy way to rename your virtual machine. Why? Because Kubernetes don't need to have this. That's all. There is a, how to say, ability to do this. You need to delete the object non-recursively and create a new object with different name, but with the same, for example, the claim for the disk. And after this, the virtual machine is renamed, but this is not easy. This is a tricky. Okay. This is the question from our someone on the chat. How to add or remove resources into container world? Paweł, do you have?
How to add it?
Yes.
Just bring new
yes.
to hardware. It's not easy.
No.
Is it possible?
This is not option. If you are using the components like container, like pod, you just scale up a new pod with new resources and descale the old pod with old resources. I'm sorry, exactly the same is in the virtualization. You need to shut down your virtual machine, add or remove some resources, and spin up your virtual machine again.
Good news is that it's doable, but you need to switch off. So
It's
worse for that if you have application 24/7.
We have some ability to add some resources on the fly. For example, now is available for the disk. You can add new disk without any restart. But for example, the network needs still have to be rebooted to show the new network interface.
Let me just jump in. Sorry for that.
How to shut down VM? I try to show you because this is absolutely very funny. I try to. I'm sorry. There is no option to share my screen.
Oh, just describe.
Okay.
Sorry for that.
Okay. No problem. If you log in into, for example, this new virtual machine, put the command power off or shut down or everything to stop your virtual machine. The Kubernetes speed up this machine automatically. Why? Because this is normal behavior for pod. If pod was crashed and shutdown is crashed from the OpenShift point of view, the virtualization platform, like OpenShift Virtualization, speed up your virtual machine. The proper way to shut down your virtual machine is using a button or command directly from OpenShift, not from inside virtual machine. Okay, there is some links to deep dive about this technology.
Yeah, so let's just a little bit go. So we have OpenShift virtualization, we have a KubeVirt. So we need to be aware that OpenShift virtualization is based on a KubeVirt technology.
That's right. This is upstream for OpenShift virtualization.
Yes, so it's upstream. Good to see that there are some demos. So if you would like to just play or get more information, just go there. And I also see the labs and workshops available from the Red Hat perspective. Now, so also. So thank you for all of the attendance. We planned 45 minutes and it's 46, so it's exactly minus the technical issues that we got from the beginning. I apologize for it, but hopefully we went with Zbigniew through all of the information. I just found one more question, Zbyszek, to us. From this demo, using the pod networks, I presume we could add those VMs to the load balancer. Is it true?
Load balancer, ingress, every of those technology which is implemented in the OpenShift, in the Kubernetes, was available for virtual machine. And again, if you need a classical bridge, you just need to create a new interface or replace this interface as a bridge interface, and you can run this machine exactly the same like in VMware, like in Ref technology.
Beauty. So if I believe we answered all of the questions. That was really informative webinars, Bishek. It was, lots of good stuff, lots of even demo, etc. Even if we have these issues from the beginning. So for all of our attendants, so thank you for the participation. If you will find right now this movie on YouTube, if you will have any other questions, just please first of all subscribe to the OpenShift Virtualization, and if you have questions, just put a comment. The small addition from my side, we just finalizing as a store backup and recovery platform, backing up and restoration process for the OpenShift virtualization. We already have the OpenStack, RHV, OpenShift, Ceph, and we are just lack of this one technology. So I'm really keen to have it. It will be available in the next version 6.0 store, which will be available on July this year. So for sure, next webinar, Zbigniew, I will bring you here and we will play a little bit with the backup and recovery features. And I'm curious, from the restoration perspective, we should be able to rename it. It will be the part.
Yes, maybe.
This will be the part
That's
of the
right.
migration process.
That's right.
So let's take it as a one of the examples. So for all of you, again, thanks a lot, Zbigniew. It was a pleasure, like always. See you on one of the next Open Virtualization Pro webinars. Thanks. Have a good day.
Thank you. See you again.